My name is Mark Baumgartner, and I'm from the Woodsole Oceanographic Institution. I'm going to talk today about near real-time passive acoustic monitoring for right whales on the U.S. East Coast, and this is an update of talks I've given at past consortium meetings. The monitoring system we built at WHOI is based on the Digital Acoustic Monitoring Instrument, or DMON, that we've incorporated into several autonomous platforms, including Slocum gliders and moored buoys. The DMON on these platforms operate in the same way. They send detection information to a shoreside server via the Iridium satellite system every 2 hours, where it is immediately displayed on a publicly accessible website, robotsforwhales.whoi.edu. The detection data is reviewed by an analyst who determines whether whale sounds are present or not. The results of the analyst review are posted on the Robots for Whales website and directly distributed to stakeholders via email or text messages. The data are also shared in real time with a variety of web platforms and apps such as WhaleMap, Whale Alert, Mysticetus, and the Coast Guard's CG1 View software. We published a number of papers describing the system and its accuracy. In the past year, we published a paper on the use of the DMON to detect baleen whales from wave gliders, a type of surface autonomous vehicle. Hansen Johnson also has a manuscript in review that estimates the detection range of Slocum gliders and moored buoys equipped with the DMON system. To date, our near real-time detection system has been used to trigger NOAA's slow zones in the US and fishery closures and ship speed restrictions in Canada. I'll now briefly describe the glider and buoy deployments that occurred in the past year. You'll note on this map that there are glider deployments by my colleagues in Canada, but I won't discuss those today. Over the past year, WHOI operated buoys in the New York Bight, off Martha's Vineyard, and off Atlantic City, New Jersey. The New York Bight buoys, circled here in red, are operated in partnership with the Wildlife Conservation Society and are funded by Equinor, a wind energy development company. The Martha's Vineyard and Atlantic City buoys, circled here in green and yellow, are funded by Ørsted, another wind energy development company. During the past year, we deployed 2 new buoys off Ocean City, Maryland, and Cape Hatteras, North Carolina. The Ocean City buoy, circled here in green, is operated in collaboration with the University of Maryland and was funded by the Maryland Department of Natural Resources. We just had our first right whale detection on that buoy at the very end of September. The Cape Hatteras buoy, circled in yellow, is operated in collaboration with and is funded by NAVFAC Atlanta. Nearly all of our buoys had Iridium connectivity issues this past winter, which accounted for a few months of downtime for each buoy. The problem was traced to a design flaw in the antenna housing, which we have since fixed in all of the buoys currently at sea. For Slocum glider deployments over the past year, surveys of coastal New Jersey waters were conducted by Rutgers University with funding from Ørsted. Rutgers completed several glider missions throughout the fall and winter of 2020 and 2021. My glider fleet at WHOI was used to support several missions, including serial deployments near Cox Ledge, south of Massachusetts and Rhode Island, circled here in yellow. These deployments were conducted in collaboration with the NOAA Northeast Fisheries Science Center and were funded by BOEM. We also operated gliders continuously from December to July in the Stellwagen Basin region, circled here in green, as part of the Navy's Sank Sound project in collaboration with the NOAA Northeast Fisheries Science Center and the Stellwagen Bank National Marine Sanctuary. Finally, we deployed a glider for our annual wintertime survey of the northern and western Gulf of Maine, sponsored by narwc and in collaboration with the NOAA Northeast Fisheries Science Center. The glider was deployed in December off Cutler, Maine, near the U.S.-Canadian border, but it had numerous problems that required several recoveries and redeployments. I dubbed this the glider mission from hell, which only operated correctly during the western Gulf of Maine portion of the survey. In this map, I'm showing right whale detections overlaid on the glider and buoy locations. All but one of the platforms detected right whales at some point in the past year. In all, these platforms conducted 1,727 days of monitoring, of which 126 days had right whale detections. Looking forward, there will be some additions to this monitoring network in the next year. With funding from the Broadreach Foundation, Neil Pettigrew's group at the University of Maine has incorporated a DMON into one of their Slocum gliders and will be operating a glider this fall in the northern Gulf of Maine. We will also be adding 2 new buoys off the coasts of Norfolk, Virginia, and Savannah, Georgia, with funding from CMA CGM, a French shipping company. As many of you know, right whale moms can be rather quiet on the calving grounds off the southeast U.S., so we will be interested to see how well the Savannah buoy performs relative to sighting effort in the region. I'd like to thank all of our partners, the WHOI engineers and technicians and analysts that have made this work possible, as well as our funders. And thank you for your attention.